Hello, in this video I will show you how to design an automated test architecture from scratch using a small training project. We will do it in the same way we would do in a real job. Even when AI writes the code, a person still needs to understand the main idea and the overall concept. The test automation repository is available on GitHub. You can download it and continue experimenting with it. The application itself is deployed on Heroku. Try things out, learn and improve. There is always room to make a project better. You may find ways to make the original project even cleaner and more powerful, and later, please share your results with me. But first, let's look at the application, what we are going to cover with automated tests in this masterclass. It's a simulation of a commercial web application. It has several dashboards that display different types of data. In our story, this data is stored in a database. The application has both a backend API and frontend. One thing we can notice right away is that all dashboards follow a similar design. They look very similar to each other. We can add new data to every dashboard, and the flow for adding data is very similar. We would create automated tests to check that the dashboard load correctly and work as expected. We will check that we can add a new asset on the asset dashboard, add a new project on the project's dashboard, and log into the application. These are UI tests. For the API part, we will create a test that checks whether we can reset the dashboard data back to its original state. And one small note, in this demo project, the data is not really stored in database, it's stored in application memory. One more thing, if several people run the same tests exactly at the same time, some tests may fail because they can interfere with each other. That's actually part of the learning experience. You can open the report, look at the screenshots, videos, and think about why a test failed. Just remember that several people may use this platform at the same time. For example, one person may add new data while another person resets all data. This can create conflicts. So what do we have in this project? We have several directories and configuration files. Let's start with README. It explains that we have API tests and UI tests. The project uses the page object pattern. These automated tests are created for a specific application. The application can run locally or be deployed on Heroku. For this masterclass, I deployed it on Heroku for you. You can find the link. I also created the application itself. To run the test, you need to have a file called env. This file contains the URLs of the application that you want to test. Just take the env example file and remove the example part from its name. Then you will have the file you need. As a good practice, I added env file to gitignore, so I don't push it to GitHub. You can also find all the commands for running the tests in the README. You can run only the API tests, only the UI tests, run the tests with a visible browser, and open the report. One useful option is running the tests sequentially in real mode with only one worker. Let's quickly go through the configuration file. The first one is gitignore. It contains everything that we don't want to Git to track or push to the GitHub repository. Global setup is code that runs once before all tests. In our project, it logs into the application and generates an authentication token for all UI tests, so we don't need to log in again inside every test. Package.json is the manifest file of npm project. Page.log.json logs the exact versions of all dependencies used in the project. You don't need to edit this file manually. Playwright config is the main shared configuration file for the Playwright framework. Here we define where our tests are located. We can group them, give each group its own name, and define which browser should run the tests. Please notice that for our UI tests, we define where Playwright should take the authentication token from. This is the same token that was generated in global setup. And base URL is the address of the application we are testing. And this is where we define where Playwright should get it from. Now let's open Playwright config file. In this configuration file, we allow Playwright to retry a test if it fails. For the retry, we generate a trace. We also generate screenshots and videos when a test fails. Why do we do this only for failed tests? Because screenshots, videos, and traces use resources. They take time and CPU. When many tests run in CI pipelines, these become important. In the config, we also define where to find global setup, where our tests are located, and which file pattern Playwright should use to find them. Fully parallel means that we allow all tests to run in parallel on different workers. By the way, in this config, I don't limit the number of workers. If your computer is not powerful enough, this can become a problem. So what is the worker? Playwright run tests inside workers. Inside one worker, Playwright starts browser and runs tests there. To make the execution faster, Playwright can use several workers and they are isolated at the same time. Then tests run in parallel and the whole test run takes less time. tcconfig is the TypeScript configuration file. TypeScript is the programming language used in this project. For the lesson, we don't need to focus on this. Now let's look at the tests. We have two types of tests, UI and API. How are the UI tests organized? We have 7 spec files. These are the actual test files. What do they check? They cover creating an asset and cancel scenario, logging through the login form, displaying the assets dashboard, displaying the project dashboard, creating a project, and cancel scenario. The tests themselves are short, clean, and easy to read. But for them to stay in this way, the UI directory contains many other folders, and each folder has its own purpose. When we look at application, we noticed many repeating patterns. The dashboards are similar to each other. Creating assets and creating projects also follow a very similar flow. That's why in this project I decided to try an architecture where each dashboard is a small component. Later, this component becomes part of page object, part of page. For dashboards, we have a base component. It contains the methods that are shared by all dashboards. The other dashboard component extend this base dashboard component. Then inside page directory, I describe each full page. For example, asset dashboard page contains asset dashboard component, and project dashboard page contains project dashboard component. Some people may say this is too complex, but my main idea is simple. When you see repeating components in your application that are reused in many places, it can make sense to create separate component object and reuse it inside page objects. I used a simple approach for the pages where we create assets and projects. Here, I don't have separate components. I only have a base create page, which contains reusable methods, then create assets page, extends those methods and adds its own unique methods. The same is true for create project page. It extends the base page and adds project-specific methods. So what is page object? A page object is basically a class that represents one page of the web application we are testing. This class contains the elements and methods that we use to work with this page. Here's a very simple example. Inside the create project page object, we have a method that clicks the cancel button. Then we need this action in a test. We simply call this method. The main value of the page object pattern is that all locators are hidden inside the page object. The tests themselves don't contain locators. So when developers change something in the UI, you don't need to update every test. You only need to update the page object, change the locators, or update the methods. The tests should stay the same. Good. Going back to the base components, they also contain waits for page loading and loaders to disappear. This usually helps reduce flaky tests. Flaky tests are tests that sometimes pass, sometimes fail without any real product change. An important part of the UI test architecture in this project is fixtures. A fixture is a prepared object or context that Playwright creates and passes to the test through its arguments. Fixtures help us avoid duplication in our tests. Our main fixture is the UI test fixture. It uses test extend and adds the page object that you can see here. The idea is that every test receives ready-to-use object. So inside the spec files, we don't need to create these objects manually every time. Also, the UI test fixture extends the API test fixture, which is located in the API directory. This means that UI tests receive not only ready UI objects, but also API clients and token from the API layer. That's why in UI spec, we can write a clean before each like this. This helps us keep our tests independent. Before every test, we reset the data back to its original state. Now let's look at some common mistakes in UI test architecture. What could be wrong in this project? First, we could skip the page object and component layer and put locators directly inside the spec files. Then the tests would become fragile and the same selectors would be duplicated in many places. Another mistake is not using fixtures and creating all objects manually in every test. This adds a lot of noise to the tests. We could also forget to reset the data in before each. Then tests would start depending on each other and could fail randomly. Each test should always be independent. Another common mistake is using unstable waits. For example, using wait for timeout instead of meaningful waits based on the application behavior. It's better to use waits through page object or component methods. Wait for loaded, expect visible, expect URL, and similar checks. Don't just wait for 2 seconds and hope that page is ready. Another important point is stable selectors. Also don't forget about unique test data in create flows. Don't hard code names or values because this can create conflicts between tests. In our create project flow, the input data is generated uniquely. This is the correct approach. Another mistake is checking only that something opened or that navigation happened, but not checking the business result. A test should focus on the business outcome. For example, not only the create project page opened, but that a new project was actually created and appears on the dashboard. You can also make the architecture worse by breaking the abstraction of base classes. Don't duplicate logic if it already belongs in a base class. And finally, don't forget about parallel execution. Tests should be written in the way that they can run in parallel and still stay independent. These are the main points. Now let's look at the API tests. The main idea of API tests is that they check the backend directly without using a browser. They are faster than UI tests. They also help us prepare stable data for UI tests, and they are useful for catching regressions in API endpoints. At work, we often use this approach. We write one or two good end-to-end tests, UI end-to-end tests, and then add several end-to-end API tests to cover different variations of the business logic. This is usually easier to maintain than creating many UI tests. For API tests, we normally have clients. The first important client is HTTP client. It's the base transport layer. It sends requests and checks that the requests were successful. Then we have domain clients. Each domain client knows its own endpoints for logins, for resetting data, for creating a new project, or for creating a new asset. We also have an API test fixture. It creates a request context from with the base URL, initialize all API clients, and gets the token. And then we have the spec files. They are very simple. They check that token is returned and that the reset endpoint restores the original data. For this demo project, these API checks don't have a lot of business value by themselves. The main value of the API layer is that the UI test fixture extends the API test fixture. This gives us UI tests access to an API client and helps keep their test data stable. Now let's briefly look at common mistakes in API tests. One common mistake is importing the regular Playwright test instead of the API test fixture. Another mistake is creating only that the response status is okay. A successful status code is not enough. You should also validate the data contract, the response structure, and its content. Other common mistakes are not resetting data, hard coding URLs or credentials, handling authentication incorrectly, for example, forgetting to pass a required token, skipping API clients and writing requests directly inside spec files, and finally, not understanding the difference between API tests and UI tests, mixing their responsibilities. There are still things that should be fully covered by end-to-end UI tests. But moving absolutely everything into UI tests is also expensive and tiring to maintain. That's it for today. I tried to make this masterclass as simple and clear as possible. And as always, I want to support the video with practical materials, not only with explanations. You can download everything using the links in the description. You can explore the project, click through it, run tests and experiments. Good luck, keep practicing.